Hello, everyone. Welcome to section 1.1, part 2. We're going to keep talking about real numbers, and in particular, in this part, we're going to delve deeper into sets and set builder notation. First, let's talk about some other or a different set operation. Let's talk about set difference. So before we discussed unit and intersection, and this is another way to combine sets. So if we let A and B be sets, so just any sort of whatever sets, we say A backslash B, which we read is as A take away B. So if you've got A, let's draw it as a circle. Got your set A, collection of things. And let's say you've got another set B right here, draw it as another circle. The set A take away B is everything in A except the things that are also in B. So A take away B looks like this. That's A take away B. It's that red shaded area right there. So if we wanted to see this in action with intervals, for example, we could do something like this. We could do like the interval 0 to 2 closed. And then just for kicks and giggles, let's take away the singleton 1. So we're only going to take away 1 point. Let's go ahead and draw these out of number lines so we can really see what's going on here. So let's do 0 to the closed interval as we've been practicing. So that's going to start at 0, filled in, it's the bracket. And it's going to go all the way to 2, which is right here. That's also filled in. And then it's everything in between them. OK. And then just so we've got a reference, let's go ahead and draw the singleton 1. So that's going to look like just a dot at 1 right here like that. And now we want to take away 1 from this interval 0, 2. So we're going to do the red thing, but we're going to omit all the blue. So what that'll end up looking like if you drop things down, right? You're still going to get 0 filled in. You're still going to get 2 filled in, right? Because the blue doesn't touch either of those. The blue is this thing right in the middle. So what's going to happen to this red line is it's going to get a hole punched into it right at 1. So it'll be a 1, right? Or an empty circle right there. And it's everything in between the circles, but just not 1. It comes from that blue dot right there. So this is 0, 2, take away the singleton 1. Cool. So this will be helpful notation for you to use especially when we're talking about functions, computer domains, et cetera, et cetera. You don't have to use this notation. You can just stick with writing it as 2 intervals. So you could also use 0 to 1, open, union, 1 to 2, like that. You could also write that interval this way. Between these two, it's really just taste as to which one you prefer. OK, so let's do a quick sort of summary. So our operations are thus. So far, we've got 3 of them. And these are going to be the ones that we're going to focus on mainly. So we've got U for union. We've got this weird N thing for intersection. And then lastly, we just talked about this, which was exclusion or set difference. Exclusion. And so when you see these symbols, I want you to, in your mind, associate them with some words. So the union is the or operator here. The intersection is the and operator, and the exclusion is the not. OK. Take a minute and think about that and try to see like why do each of those correlate with each of those words? The nice thing about having these words is that they can make doing these kinds of things where you convert from one form to the other, it can make doing this kind of move easier. If you think about the union as an or, the intersection is and the backslash exclusion as not. And this will become extra helpful when we talk about our set builder notation, which I did mention briefly in the previous video, but now I want to go into it in more detail. And to do that, I'm also going to introduce some other very common symbols in math that I'm going to show you now, just so you kind of know what they mean when I write them down. And then you can also use them in your homework, of course. So the first one is this weird looking Z thing. This is called, this font, this typeface is called Blackboard Bold. Then a Blackboard Bold capital Z is the integers. Similarly, if we have this Blackboard Bold R, so this funky looking R here, that's going to be real numbers. These are just shorthand, so we don't have to write out the word integers every time. And then lastly, a little bit different, is it's going to be this weird E looking shape. And what this means is element of. And that might seem a little strange, so let's see it in action. So if we were to write 2 element of R, what this is, you can say in English translated, this would be 2 is in the real numbers. Right, where the 2, of course, is 2 right here, is in comes from the E looking symbol thing there, and then the R corresponds to the real numbers right there, like that. So we can use these symbols in our set builder notation. And if you recall, set builder notation is when you write down a set and has the 2 parts, and you've got the curly brackets on the outside. So let's see that again. Let's write some things in set builder notation. So the set of all real numbers greater than 5. So as with last time, we start with the curly bracket, and then on the left side, we put in the bigger category. In this case, and basically in all cases that we're going to deal with in this class, the bigger category is the real numbers. So we'll always, or almost always, start off with X in R. So what we're saying here is that our set is going to be the set of all things in the real numbers. So all real numbers such that, and we want to have this greater than 5 restriction. So we'll just put X is greater than 5. And then we'll do another curly bracket to indicate the set is done. So remember, this is the broad category of things that we're looking at, and then this is the restrictions on it. Let's make this a different color. So this, the right side is restrictions or conditions. We can integrate more complicated sentences or ideas into set builder notation, which is what makes it so useful, is because it's versatile. So let's say we wanted to do the set of all real numbers. And let's do them smaller than 3 or 1 less than 5. So yeah, so looking at this, you can kind of see there's 2 things going on here. We've got this, you know, you've got the set of all real numbers, the setup, the category, right? And then you've got smaller than 3. And then you've got this or, which right now your mind should be pinging. You're like, oh, or, we know what that is. We should think union. And then we've got this 1 less than 5 going on here. So let's see if we can break this down. So we'll start off with curly bracket, X is in R, such that. So we're starting with a set of all real numbers, and then we're going to do so X is smaller than 3, just the same as last time. And then when you're doing separator notation, the nice thing about it is you can just use English. You can try or. And then 1 less than 5 is a little more enigmatic. But you see something like this, you're like, okay, we want all real numbers so that they are less than 5. So we want all real numbers X such that when we take away 1, they equal 5. And that's how you would write that explicitly. And then a curly bracket at the end, of course, to close it all off. Excellent. So let's do a couple more examples because step builder notation can be really tricky to get used to. So let's say we've got an interval like 0, 2. Let's make this end open. And let's say we wanted to write this in step builder notation. So we'll just start with X in R, such that. And then we just want everything that's in between 0 and 2, not including 2. So we'll just write that as that. So it's all X and R such that X is greater than or equal to 0 and less than 2. There's secretly an and sandwiched in there. Okay, maybe let's see a different example. Let's do maybe, all the way down to negative infinity. Let's do 3. And then let's go ahead and take away 0. So let's draw some pictures because this one's a little more complicated to kind of see what's going on. So what we're saying is we've got, so starting at 3 filled in because it's a bracket, and then it's everything less than it. And then we're taking away 0. So there's going to be this hole at 0. So we'll just fill it in like that. Okay, so this is what the set looked like. You've got this hole at 0 here, but then it's 3 and everything smaller than it. If we wanted to write this in separator notation, the way we could do this is we'll do our usual X in R, such that. And so what I'm going to do is I'm going to do X less than or equal to 3. And then I'm just going to put a comma. You can also write and X is not 0. So this, again, demonstrates why set builder notation is so nice, is because you can easily form things with it. You can make very complicated sets using set builder notation very easily because you can use some English in there. You just have to be careful not to be too nervous about it. Like or, and, not, those are really the only words you really want to see in set builder notation. Okay, let's do one more example before I let you go. And let's look at starting at set builder notation and going to interval notation. So let's do X in R. And let's do something like X equals -1. Or this or should ring a bell. X is in the open interval 0 to 2. Oops. Sorry about that. Open interval 0 to 2. Okay. So this is weird because you've got, this seems fairly straightforward, the X equals -1. And we've got this or, which we know kind of how to deal with. And we'll see in more detail in a second. And we've got this X in 0, 2, which is like, what? The element sign inside set builder notation? This is too complicated. Well, let's just take it piece by piece. So let's draw some pictures so we can really kind of see what's going on here. So we're looking at, let's look at the red first. Sorry. So the red is just X in 0 to 2. So let's just draw 0 to 2 open. So we're going to leave those unshaded and everything in between them. And then the yellow is X is equal to -1. So that would be down here. Okay. Now this or, if you remember from our previous discussion, or should ring the bell union in your head. So what you can think of is we're going to take the yellow set, we're going to take the red set, and we're going to union them together. And as you know from our previous video, if we union these two sets together, we will simply get this right here, right? Where that comes from there, 0 from there, and that from that. So this blue is what the union would be. So we can write that out. We can just do 0 to 2 union this singleton -1. And so that is what this set builder notation means, is this interval right here. All right, that was a lot of sets. They will get easier the more you practice them, so don't be too worried about them. The homework is excellent practice for these kinds of concepts, but of course, if you get stuck, you can always ask me questions.